Hey folks, today we're going to be going over navigation using map and compass. It's important to know how to navigate using a map and compass because when GPS and all of our other technology fail, it is our #1 source of navigation. So the first part about map and compass navigation that we need to know about is how to read a topographic map. So topographic maps are called topo maps because of all the little lines here that cover the map that are called topo lines or contour lines. So these topo or contour lines symbolize different terrain features that you'll be encountering in mountainous terrain. The easiest way to describe them would be imagine a giant string strung around a mountain and then laid flat, and that would be the shape of your contour line. So we can infer from that and find different features on a map. So if we want to find the top of a hill or the top of a mountain, we might look for circles getting smaller and smaller and smaller. For example, this small hill right here, where we have a little circle, and then it gets bigger and bigger and bigger, or like Signal Peak over here, which continually gets larger and larger and larger. We can also see that there's little streams here, so you'll see them in blue here, but if we want to see if there's like a ditch or a gully here, we can see that there's V's in the mountain pointing upwards towards higher elevation. So those are a couple different features that you can look for on a map. It takes lots of map reading experience to really be able to visualize what the terrain looks like from just reading a map. So I do also want to mention about contour lines and topo lines here. Right here on your map scale, you'll find your contour interval. And on this map, it's 50 feet. So that means between all of these little lines, we have 50 feet. And you can also notice here that there are contour intervals at a 250-foot range that are a bit darker. So every 5 lines on this map, you'll get a bit darker line. And those ones will also mark the elevation. So this one says 8,000 here, and this says 8,250 because there's 5 lines in between them. Here at the top of the map also, you can also find your legend, which is going to tell you about all the little different things on that particular map you'll find and what they mean. Also, you'll find the scale here. So this approximate scale is 1 to 40,680. So what does that mean? That means that any one object in real life would mean that there's 40,680 of those lined up on the ground. So if I were to take this pencil and lay it here on the map, between this point and this point, you would have 40,680 of those pencils in a row in real life. That also works with inches, feet, or whatever object you want to move that onto. So one last thing I do want to mention before we move on to parts of the compass is that maps are going to be measuring in true north and compasses will be measuring in magnetic north. So remember that for the rest of the lesson, and that will help you a lot. So the next part about map and compass navigation we need to go over are the parts of the compass. So on Western Mountain Rescue, you'll need a compass that has a base plate like this and a rotating dial like this. My compass also has a hinged siding mirror here, which you do not need, and that allows you to look at your compass while you are taking a bearing through this little hole, so you can adjust that and get a slightly more accurate reading, but that's not mandatory. A lot of the compasses you'll have will have a little arrow here that is your direction of travel arrow. A lot of the times it'll say read bearing here on your compass. You'll also have this index line, which is helpful for lining up your numbers with your rotating dial here. So if I wanted to find 60, you can see that 60 lines up right here. So this right here is our orienteering arrow, and this right here is our magnetic needle. These lines across the middle of the compass, right now I have them parallel. Those are our meridian lines. So make sure you remember those because I'll be referencing those later in this lesson. So those are all the main parts of the compass that you'll need to know for this lesson and navigating on Western Mountain Rescue. So the next part about map and compass navigation we need to cover is declination. At the beginning of this lesson, we mentioned that maps measure in true north and your compass is going to measure in magnetic north. Magnetic north is approximately 500 kilometers south of true north, but it is constantly moving because the magma in the earth is moving. The difference between true north and magnetic north is known as declination. Because they are several hundred kilometers apart, we do need to be adjusting our compass so it measures in true north, because that's what our map also measures in. So the line between true north and magnetic north is 0 degrees right here. And as we move out this way, you'll get higher and higher and higher degrees of easterly declination, and as you move out this way, you'll get higher and higher and higher degrees of westerly declination. So that is shown in this chart. So here is that agonic line, that line of 0 declination. So if you're on this line, you wouldn't need to adjust your compass at all. But as you move out, you can see that you're going to have to adjust your compass more and more and more the farther you get away from that agonic line. So we're here in Gunnison. And at the time of filming this video, we're at 10.95 degrees east declination. So we'll round that up to 11 for the remainder of the video. Usually we'll be rounding that number because it makes navigating significantly easier. So because of that, we want to be adjusting our compass to get back so it reads at this 0 degree line. So all we're doing with our compass to adjust it to true north is adjusting it so it acts like we're reading here on this agonic line of 0. So that's important moving forward with map and compass navigation. So because of this declination, we're going to need to adjust. So here on the west side of the agonic line, we have easterly declination, so we'll be needing to adjust our compass to the east. So in order to do that, if we have a magnetic bearing, which you'll see here in just the next section, if you take your magnetic bearing and you want to convert it to true, you'll spin your compass dial 11 degrees towards the east so you can make up for that declination. And vice versa, if you had that true bearing or something true north that you wanted to convert to magnetic north, all you would do is simply subtract. So if you had 11, you'd subtract that down to 0. Some compasses, like mine, you can adjust them with a little tool on the back, so you never have to actually make that adjustment. Also, I have seen that you can draw on with a Sharpie onto your compass so you have that declination drawn on, but I don't like doing that because I feel it changes quite a bit, and a small degree could mean miles off of your destination. So I do want to mention that these here, magnetic north to true north equals add 11 degrees if we wanted to convert these, and if we wanted to convert true north to magnetic north, subtract. But if you're on the East Coast, those are going to be opposite because you have westerly declination. So, for example, if you're here at 15 degrees west on the East Coast and you wanted to convert those, it would just be the opposite to convert magnetic to true, and you just subtract that 15 degrees. Rather than on the west side of the agonic line where we have easterly declination, where you would add that 11 degrees for Gunnison here. So now let's go out to the field and I'll show you how to take some bearings and implement this into real life. So we can use our map and compass to take bearings. Bearings are the direction from one place to another, measured in degrees of angle with respect to an accepted reference line. That reference line is typically true north. Bearings can be taken and plotted on a map, and they can also be taken and plotted in the field. Let's go try it. So now I'm going to show you how to take a bearing in the field. So on your compass, you'll have this sighting mirror or a direction of travel arrow. Most likely the direction of travel arrow, so that will be a little arrow at the top of your compass here that you'll just point at whatever you want to take a bearing of. So right now we're out here somewhere on Flat Top Mesa, and I want to take a bearing of Signal Peak. So to do that, I can look down through my sighting mirror and align my compass until we say red is in the shed. So we'll get this red arrow aligned up in with the other red arrow. And to do that, your hand does need to be flat and away from other magnets. So as you can see here, I'm sighting Signal Peak in there. Red's in the shed. Now you can see we're at about 174 degrees. Now, we want to convert that to true. This is a magnetic bearing. So let's add that 11 degrees. So 174 plus 11 is 185. So that's 185 degree true bearing over there at Signal Peak from my location. So next is plotting a bearing in the field. Now, with plotting a bearing in the field, you'll be given a true bearing and you'll need to convert it to a magnetic bearing. So let's say Ops has given you a bearing of 55 degrees and they want you to follow that. So first thing we're going to need to do is convert that to magnetic. So 55 degrees true minus 11 is 44 magnetic. Next, in order to plot this bearing in the field, we're going to spin our dial until 44 is at the index line. And then we'll rotate our body until red is in the shed once again. And now you can look through your sighting mirror, line up, and you can see that 44 degrees or a 55 degree true bearing is right about at Mount Evans. So we just went over plotting and taking bearings in the field. Now I'm going to show you how to plot and take bearings on a map. So in this case, we're going to pretend we're on top of Signal Peak. And we want to plot a bearing of 281 degrees. So at this point, our maps are in true north, and we're using our compass as a protractor. We're not using the magnetic part of it, we're just using the numbers and the line part of it. So we can plot it as a true bearing. So first step, we spin our dial to 281 degrees. Second step is we get down to our map and find that Signal Peak right here. Now ideally we're on about as flat of a rock as we can find, but we want to ideally as level of a surface as you can. So these meridian lines here on your compass, you're gonna get the corner of your compass there and you're gonna rotate your compass until these meridian lines are north-south. So now they're about north-south. It's a little bit bumpy here, so this won't be 100% accurate. So the smoother you can do this on, the more accurate it'll be. So let's draw that on there. And now we just plotted a 281 degree bearing from Signal Peak. Now this is just using the protractor part of our compass again, remember that. Also, notice how this rock that this map is sitting on, these are slightly magnetic. So they would impact it anyway. Next, we're going to be going over how to take a bearing on a map. So we're going to use similar two peaks, Signal Peak and W Mountain. So in order to take a bearing on your map, first step would be you need to align your compass from Tenderfoot Mountain and aim it at Signal Peak. So we know Tenderfoot's right here and Signal Peak's right here. So let's aim those. And I'm gonna use, this is not 100% accurate now. If you had a ruler and things like that, you can get this more accurate. You can line up another straight edge here, but I have this fairly straight. Here's Tenderfoot Mountain, and here's Signal Peak. Now this is very similar. Now all we're doing is rotating our dial until those meridian lines are again north-south. And then you're gonna read that index line right here to find out what that bearing is. So you can see here at the index line, it is reading 20 degrees. So from W Mountain or Tenderfoot Mountain to the top of Signal Peak, we have approximately a true bearing of 20 degrees. So we can use those bearings that we now know how to take and plot and take multiple bearings in the field, plot them on the map, and then cross them to find out exactly where we are. This process is called triangulation. When triangulating, you're going to be looking for several criteria. One, you need a flat or generally open area where you can see multiple peaks that you are able to determine what they are and where they are on the map. Two, ideally those peaks are approximately 90 degrees from each other. If you have these criteria, you can triangulate your position. So today we've come out to Flat Top Mesa near Almont, and we want to find out exactly where we are on top of Flat Top Mesa. So to do that, I'm going to grab my compass here and take a bearing of W Mountain over there. So let's get that approximately lined up. And looks like W Mountain is at approximately 180 degrees from myself. So this is a pretty easy bearing to convert to the opposite bearing, which would be 0 or 360. All you do is add or subtract 180 degrees. Now, if you have a different bearing that's less than 180, you're going to add 180, and if it's greater than 180, you'll subtract to get that opposite bearing. The opposite bearing is essentially what someone on top of W Mountain would be taking of us. So now we can do that. We know that the opposite of 180 is 360 or 0. So I've rotated my compass now back to 0. Now, these are still all in magnetic bearings. Now, because we're going to be plotting this on a map, which is in true north, we're going to want to convert this bearing to true north. So let's add 11 degrees to that. So now I've added 11 degrees. So now, similar process as we did when we were plotting a bearing on the map, it's actually the same thing, is let's get our corner of our compass here on Tenderfoot Mountain and line these lines up to be approximately north-south, right about there. And this works best on a flat surface. Now, sometimes with these, you are going to get very unlevel surfaces and you won't have it as accurate. So ideally you're doing this on some sort of table, but in the backcountry, like I am now, you need to improvise. So here we are. Find those lines again. Let's keep bringing them up. So now we have one of our lines drawn. We're somewhere along this line in this region. Now, I do apologize, this is very hard to see on this map with this pencil because it is a somewhat waterproof map and this pencil is hard to do and I don't want to write on my map with pen. So imagine a line that we plotted from Tenderfoot Mountain here to Flat Top Mesa over here. Next, we're gonna need our second peak or second point. So I am going to use the little hill over here. There's just a small hill down there, and based on my map, I can look around at different terrain features to find out approximately which peak that is on the map, and then I can take a bearing of it and then plot it from that point on the map where I know that peak is and cross those two lines, and that's where I'll be. So let's do it. So we have this small little hill right there. I'm going to rotate my compass dial. And notice this small hill is at approximately 90 degrees from W Mountain, which is over there. So this is here, W Mountain's over there, probably a little bit less than that. We are at about (118 degrees. So from 118 degrees, we're gonna wanna add 180. So to get that opposite bearing. So 118 plus 180 would be 298 degrees. So we know that the bearing over there is 298 degrees. Looking there towards us. Now that's in magnetic. Now we're going to convert that to true again. So 298 plus 11 would be 309. So now we'll rotate our compass to 309. Find that little peak. So we know we're somewhere here on Flat Top Mesa. And I do know that little peak is about right here. So now I'm going to get that little peak in the corner of my compass once again. And unfortunately, here, I'm gonna pull this down just a little bit flatter for this second point. And rotate that till these lines are north-south. And now you can see from this little peak over here to our location, and now we know we're somewhere along this line and where the other line I drew intersects. So you can, I have this other line faintly here and this line faintly here. Now I do apologize again, so they intersect right about here. And we can see that we are close to the edge of Flat Top Mesa and our lines intersected right here. So the more lines you draw from different peaks, the more accurate this will be. So if I drew a line from another peak, it might cross here, creating a small triangle, and you know you're somewhere in that triangle. But theoretically, we're close to here. Now, also, we can infer from this based on terrain features, where we are. So we know we're about right here, and that we are on top of the mesa itself. So coming up from there, we're most likely at this point right here, because that is closest to where our lines intersect and makes sense with our triangulation. And that is how you triangulate. Thank you very much. And this has been Navigating using map and compass on the Western Mountain Rescue Team. I hope you can use some of these points today in one of our next trainings, scenarios, or missions. Thank you very much.